Thank you. Wow, I really love the energy. It's 5 p.m. I was a little nervous. Am I really going to keep this session active and I'm going to really make it interesting? But thanks for the energy that you guys have shown me. It gives me more motivation. And I'm really excited to get into the conversation now. Good evening, everyone. Thanks for this opportunity. I'm happy to be presenting at FinOps X today. I know it's the last session of the conference and last session for the day as well. And after this, as John mentioned, there is an exciting poolside party as well. So I'm Anutama Chandrasekharan, known as Anu. I'm the Senior Director, heading the Head of DevOps Practices at S&P Global. My co-speaker, Guru, who heads the cloud and infrastructure globally, is unable to make it to the event due to other commitments and travel constraints that he had got at the last minute. Having said this, I would really like to move on and to share some insights about what we have done, how we have actually been able to embed AI into the FinOps practices and also other operations by moving from a human-driven approach to the machine-driven approach by introducing the intelligence, by building the intelligence, and with human in the loop as the governance, of course. Before we get started, I want to introduce S&P Global. We are the leading providers of industry ratings, benchmarks, indices across the world. At the heart of what we do at S&P is we drive the market, drive institution, drive the financial data across the world. So we have over 45,000 customers in about 150 countries. We have about 37,000 employees working globally around the clock. So what we do is, at S&P Global, at the heart of the ecosystem is, we provide data which every customer is looking for, and we provide the data for them to share, look at it, take the insights, and probably deliver it to their customers. Let's look at it in a way that, there is a customer who is awake in the morning in APAC, probably in Australia, looking for our data to provide some insights to their customer. On the other side, there is also a customer on the US East, probably in Houston, and let's take, he's an energy customer, and they're waiting for our data to determine the barrel price. And that's how we are playing a key role in providing the data and providing insights to everyone across the world. And all this cannot happen without the hard work of the global workforce that we have. To power this, we do have, we are actually running our infrastructure and application on AWS. AWS is our primary service provider. Having said that, we also have we are truly a multi-cloud company. So we do have partnership with Azure and Google, but majority of our applications run on AWS today. So the next thing is, so I really wanted to talk about how the vision started, right? So if you look at, so AI has been an integral part of everybody's life now. So if you have not embedded AI into any of the work, into any of your processes, then you're not in the game. So we, being the leaders in the financial data provider, as a financial data provider, we had to be ahead of the technology and make sure that we embed AI into our face. So by embedding AI into the face, what I mean is we have to start looking at how we can embed in the day-to-day workflow and how we can actually start providing some meaningful value to our customers. So remember the days when the industry started moving from on-prem to cloud journey. So the problem that the CIOs had to tackle was about how do we manage the cloud cost. That's when the FinOps practices started evolving in the industry. We at S&P Global also have a matured FinOps process, FinOps practices, and we have FinOps tools, and we work with the best leaders in the industry, and through this, we have been able to accomplish a mature FinOps process. So if you look at the current spend of AWS that we have is $2 billion. To drive this $2 billion AWS expenditure is not a joke, and it's not a small number too. And thanks to our FinOps team who's sitting in this room, so they've been doing a tremendous job in making sure they manage this whole spend across the organization through their robust process. So while all this is happening, when we started bringing in AI into this process, when we started embedding AI into the FinOps practices, it's not so easy because you need to make sure that you do not disturb the existing robust model. You need to build the data, and you need to build a model which could complement the FinOps process, and it should not be breaking anywhere in the whole process and the ecosystem. So this is where we kind of built our, I'm going to be talking about in the next slides how we built and what we built. And this is how we started involving the AI in our FinOps practices. So the current adoption, so if I have to say at S&P Global, there was a time, I think last year, I would say it's not so long so far. So we were actually in the race of building something on AI, and that's when we started our experimentation with AI, and it didn't stop there. I think across the organization, there were many teams, many divisions who were also exploring the adoption of AI at the same time. So the way the AI is changing the landscape is our vision was also to embed AI into every single operation, but it is not feasible if you don't have a proper centralized approach. If everybody starts building their own solution, then it is not going to be scalable at all. And there is also constant pressure at S&P Global. As I said, we need to be able to bring the leader, we have to be the leaders in technology as well by innovating and providing the data to our customers, and everybody is moving towards AI. We have to actually start providing the data. We should provide our customers feasibility to consume that through the AI-driven approach. So for this, driven by speed, autonomy shouldn't be a showstopper anywhere, and that's when the team started designing the MCPs as well, and they started designing workflows, Agentic AI workflows, but everything was decentralized. This was the classic challenge that we had when when we started moving to cloud as well. The cloud costs were decentralized. So with this current adoption approach went on, and then we also started realizing that there is a hidden cost if we go with a decentralized approach. So there is no fragmented intelligence here. So everybody is looking at their own solution, and the biggest advantage of agentic AI, or if you have to really win the results of AI, then you have to have a shared brain. You should start working towards a common decision making. You should start identifying the common use cases at an enterprise level. Only then you can be successful. Otherwise, it's going to be decentralized, and you're going to spend more cost in your infrastructure. You'll deploy the same infrastructure, observability, be it the model gateway. You're going to be deploying it multiple times across all the divisions and all the business units in the organization. And the biggest risk is also the governance. The governance is with AI, there is a lot of security standards that you have to follow. If you're not adhering to the security standards of the organization, if you do not have proper guardrails in place, if you don't have proper access controls in place, that itself becomes a huge nightmare for the CISOs of the organization. And eventually, that also brings a larger compliance gaps. And another problem that with this decentralization is also, if there are in S&P Global, we have multiple divisions. If the agent built by one division, if it cannot be consumed by the other division, then there is no point. There is everybody again starts looking at, oh, I wanted this solution, but I'm not able to consume this. And again, the result, they will start building a solution the same way. And then again, this puts us into much risk. So what we thought was, we don't want it to be decentralized. With the agentic AI adoption, at an organization level, we started building common blueprints. We started building something called Common Capabilities Approach, which is CCA, so that we can offer those capabilities as blueprint to the divisions, which everybody can consume, and start building the products to spin up the needle of the $2 billion AWS spend. The next is the core principle. So what we thought when we started building around the automation is more on the autonomous operations. We wanted the agents that can self-optimize, that can self-heal. And then we wanted that to be totally policy-driven. When I say policy-driven, agent should be secure, it should be governed, auditable at all time. And we also wanted to make sure it comes with the context of the data that is provided from which is available at the S&P Global, and it should not be providing any response from the generic models. We didn't want that. Again, if there is no value or if there is no measurable business outcome, then do not even ship the product. See, these are the 4 core principles that we consider even before we build the solution. So while I was talking about all the problems and why the adoption, all decentralization, now here is the actual problem that we try to solve. I'm sure if you look at the screen, this problem would be resonating with everybody over here. This is a common problem across the industry. Think about a time when during the development phases, a developer was able to go ahead and provision the right size of the instance. Probably the answer is no across the board, right? So we all agree to it. This is a common problem. When we start looking at when we start provisioning the instance, it's always oversized, but we never go and reassess it. And that's where, that becomes a waste. For example, right, the CPU utilization at the instance could be at 15% for over a month's period of time. Nobody goes and looks into it. This is totally a waste, but this waste gets piled up and it gets added and it starts burning the cloud cost. That is when the FinOps teams comes into picture, and they reach out to the operations team. This is more in context of S&P Global. They reach out to the operations team. They provide the Excel sheet which is downloaded from the FinOps tool about the cost saving. Looking at this is the cloud cost spend. These are the optimization recommendations. Please look at it. So then the cloud ops teams comes into picture. They look at all the instances that are over provisioned, and they look at, and there is a heavy manual dependency here because somebody has to analyze the instances, and then they have to identify who owns that resource, and they have to drop an email to the resource owner and then say, follow up with them. Since there is no governed process, emails could take from days to weeks for the owner to respond back, and then work with the cloud operations team. And then there is a debate that happens, whether this instance has to be right-sized or not. And then there is a lot of analysis within the team, and then they arrive at a conclusion. All these takes months, and at times we even start burning more cloud cost with all of these follow-ups. Again, it is time consuming since there is a lot of human process involved in the whole process. In one instance approximately takes 1 hour of manual effort for an engineer. And doesn't stop there. Once we know this is the instance which has to be right-sized, and there is a change management process which the team has to also adhere to make sure we go ahead and implement the whole solution and downsize the instance. This is just in the case of EC2s. Imagine the number of resources that we have where there is an optimization option and how many months it's going to take to even look at all the resources. The next is the scalability. As I said, if one instance could take 1 hour, consider at a scale where S&P Global is, you have about multiple instances across multiple accounts in multiple regions. It could run into thousands and thousands of instances. So this is not possible at the speed of human. And also when there is a transition that happens between one engineer to the other engineer, there is always a variability that gets introduced and errors that get introduced. So what is the solution here? So we didn't really wanted to remove the human from the loop. What we wanted to do is we built an additional intelligence layer into it. By building the additional intelligence layer, so we wanted to make sure that the pace at which we do the job, instead of at the human speed, we wanted to do it at the pace of a machine or the machine speed. If you look at the solution, it looks very simple. Go ahead and right-size all the instances and automate the end-to-end workflow. Go ahead and look at all the recommendations, go and optimize the instances, and take it to the execution following the change management process. But when you look at the practical applicability of it, it doesn't sound that easy because you still have to follow some of the processes. And that's where we kind of build this whole engine using Amazon Bedrock, and then we move to AgentCore, and which uses customized MCPs to make sure we create a conversational system. With this conversational system or the agent that we have built, what has happened is the engineer doesn't have to log into the console or run a script manually, but all he has to go is provide in a natural language, go and ask the agent, hey, where are my recommendation opportunities? What is the optimization that I can do with a minimal human input here? When I say minimal human input is required for the decision-making processes and not for the analysis or any other work job, right? That's all taken by the agent, and we have built that in the flow. So a little bit on the architectural components, how we built it, how this whole solution was built. The first is the Agentic AI operations layer. So I'm going to be a little contrarial here when I speak about this. So I'm sure many of you in this room should have access to the frontier models, be it Claude, GPT, or Bedrock. But if you look at it, the model itself is a commodity. What is the differentiator? The key differentiator here is what you build around the model, that is the harness. And what we have built in this whole layer is the harness. So agent layer controls how the agent reasons. So it actually, when a user provides a request, it decides on which tool or agent to call and in what sequence and why we are calling this. And when we're talking about what are the services we used or to build the intelligence layer and how do we do the data aggregation in the subsequent slides. But for now, so when there is the agent, in the agent framework, the agent actually decides whether it has to call the CloudWatch, whether it has to call the compute optimizer and based on the user request and provide the response accordingly. Next is the agent orchestration. Orchestration layer is very critical to handle the complex multi-steps task without changing the context in the midway. And there is also the governance that we have built in to make sure there is always the security in place and there is always this logging in place and there is an audit. Whatever agent does, it is all auditable. The next thing is the MCP Gateway Core. Here we have the identity management. At S&P Global, we use Okta for the identity and access management. So that has to be a part of the authentication for any user. But we also have another problem wherein if we have to start sharing the same agent across multiple teams, across multiple divisions, then each division should not be able to access the data of the other division. And to achieve this, only the Okta integration was not sufficient for us. So we thought, and then we kind of used the authorization design where it is Okta-based OAuth 2.0 scope-based authorization. So with this, what happens is when a user authenticates, Okta generates a OAuth token for the user with the scope, and that ties back to the business unit or the division from which the user belongs to, and then it also ties to the role, what should be given to the user and what permissions are supposed to be given to the user so that he can take the right action. When the MCP server validates the request, it not only validates the person who is logged in, but it also looks at what action the user can perform. So this way, when a person from one division, say for example, market intelligence, wants to look at the instances of ratings or energy, the request is straight away rejected by the authorization layer. It doesn't even go to the application layer. So that's a key implementation that we did. Policy engine is something, the role-based permissions, I think what operation user can perform versus what he cannot perform is taken care as a part of this. Observability is key because you need to capture every call the agent is doing, what tools the agent is calling, what recommendations the agent is giving, and what decisions are being taken by the agent. This is also important from an auditable perspective, right? So that is how, by capturing all of these in the observability platform, we are really providing a truly auditable solution and just not functional. So as a part of the audit process, you should be able to go ahead and restructure the whole reasoning chain of the agent if needed, right? So, and that's something that we have built in our architecture itself. And then comes the intelligence layer. The intelligence layer is the key differentiation of this implementation, which differentiates it from the traditional automation approach. So here, we have built this, I would call this as an analytical layer. We have not built this as a layer which is just calling multiple services, but what we have truly built here to help any user to take an informed decision. We are providing the data aggregation. What the traditional recommendations that you get from the AWS Compute Optimizer is totally based on what the service provides. You do not get any of the additional, that doesn't give the confidence for a user to go ahead and make any informed decision. But with the additional data aggregation that we are providing, it gives you the utilization patterns, it gives you the trend, utilization trend, and then it goes and looks back the historical trend as well and helps you take the decision. So for example, we get the recommendations from Compute Optimizer, and we are also using CloudWatch metrics to get the real-time metrics, and we are using Splunk to get the operational telemetry, and then we also have other services like Cost Optimization Hub, which gives the financial modeling, and so on and so forth. So while this is there, so we again have the MCP tools integration layer. MCP tools integration layer is where you have the MCP framework, and if this MCP framework is not handled well, and most of the applications do not even go to production, because they will be just at the demo phase. So here we have made our tool to be modular and reusable so that whenever there is a change, you have to go and make changes to any of the underlying modules. You don't have to, or you have to extend this capability to other services. You just have to plug and play the new services. You don't have to rework on the architecture itself. For example, what we did was in our organization, when we initially rolled it out, we were on Amazon Bedrock, and then we wanted to offer this as an MCP capability, and that's when we started actually providing the MCP server for enterprise adoption. So we moved to AgentCore. When we migrated to AgentCore, we really did not have to go ahead and rework on the engineering aspect. All we did was just use the same analytical logic. We use the same ServiceNow integration, and then we use the same tool definition. Only the change that we had to make was to the runtime and a runtime model and then the auth layer. It's how that easy it was. The other key thing which I wanted to talk about here is the API connectors. This is where we kind of connect to the third parties like Splunk, AWS, or any other service that we use to get the data aggregation. The enterprise foundation layer, I think this is something that we've already spoken about. I've already spoken about the Okta implementation, the network, and then the network security is key. We have the appropriate network controls in place to make this moving. And also, from an organization standpoint, we had to have the operational telemetry. The infrastructure logging and monitoring should be available in Splunk, so we have implemented that in our architecture. So zero trust architecture is something where you cannot trust any of the other layers implicitly. We have to make sure that at every layer we have the right authorization and we have the right trust enabled. So say, for example, at agent level, we have the Okta integration, which should reject the request if the scope is not there. At a tool level, every input request is validated against a scope. Likewise, from an infrastructure standpoint, you really cannot go ahead and implement the Rightsizing if there is no proper approvals. Okay, I know that was too much on the architecture. So now just wanted to show how much time it took for us to build this solution. We started this in May 2025, last year, as an experimentation. We kind of did a deep dive on the problem, and then by July, we were able to develop the MCP tools, and by August, we did the integration with ServiceNow to make sure this is an end-to-end implementation. By September 2025, we went live with the EC2 Rightsizing. Over a period of time, we were able to extend it to other services. We extended this to ECS, Fargate, and Lambda. And then we were also able to extend this to RDS databases by end of the year. And then we also migrated to AgentCore and rolled out our MCP offering. So this year, it's more of increasing the adoption across the enterprise. And how did the solution evolve? So when we identified the solution, we did not really roll it out at bulk to everyone across the organization. So we did it in phased approach, in an incremental approach. So first, we kind of rolled out this core solution and said we did it only for one instance to see if the results are accurate, if we can go ahead and implement it. Later on, as a part of the phase 2, we kind of incorporated the bulk recommendations. So we moved it across to multiple accounts and multiple regions. This way, we are confident that, okay, the solution that we have implemented can be scaled up to multiple instances. The next is, again, the phase 3 of implementation. Here, along with the bulk recommendations, we also added the other data aggregation to make sure it works. The data aggregation works well for multiple recommendations. And we also started providing the recommendations in an Excel downloadable format, which would really help anybody to evaluate offline. So the core concepts here, so we are looking at how do we analyze the resources based on the network utilization, CPU, memory, and then we also have capabilities to provide bulk recommendations. And in the whole process, we have also considered how we can look into the historical data, how much of look-back period we can give for the users to be confident to take the decision. And all of this, again, the intelligent right-sizing, just to make sure we can go ahead and downsize the instance. We are providing that recommendation. And then we also have the data aggregation from multiple sources. And the last one is the automated execution. In the whole process, the change management process is very critical for us. I'm sure it is going to be the case with all of you across the organization, in any other organization. So what we did was, once the agent provides a recommendation, we have the automation to trigger the change, to implement the right sizing, but we all introduce a human in the loop for additional governance. So we have integrated with the change service now, which is used for the change management workflow within S&P Global. The agent would go and create the request in ServiceNow. Whereas before the automation, it was a manual process of writing an email and waiting for the follow-up and following up with the user for the email approval. Whereas here, the change ticket the request item is created, and the request would go to the resource owner, and he can directly go and approve in ServiceNow whether if they are supportive of the decision. And to support the decision making, in the chat, we are providing, or in the chat window, we are providing additional capabilities like, the user can go and see what is the utilization, how does the CPU utilization look like for the last 30 days or 60 days. Based on what the user types, we can go back up to 90 days. And then, it'll also provide the user, to look at the network utilization, to look at how the memory was performing. And they can also look at all of these, we have done the data aggregation from different sources, as I mentioned, and we are providing it on the chat window for the agent. So that way, once the resource owner or the application owner approves, the change gets created. And even in the change process, we have given an option whether the change has to be scheduled immediately or it has to be scheduled in a change window. And then based on what the user selects, the change ticket also gets triggered, and then and we already have the automation in place to go ahead and downsize the instance, and that automation would kick in, and once if it is successful, the change is going to be auto-closed, and if not, it's going to create an incident for the operations team. This is how we have been able to connect the entire workflow, and we have made it like an agentic AI workflow from analysis, providing the recommendations, until the change approvals and the implementation of the change itself. From a time-serving perspective, so I think this is something I've already spoken in the previous slides, but if you look at the efforts, it has actually been able to provide 85% of reduction in the manual efforts, and this solution is also scalable because you're going at the pace of a machine. I think I've spoken enough. Now I wanted to show this in action, how we implemented the whole solution using the Agentic AI workflow. So this is S&P Cloud Studio. It is the chat. It's the agent or the user interface we have given to our users to go ahead and have a conversational interaction, or wherein the user can go and give in the natural language and ask. All of the instance IDs and the account, everything is fabricated for the demo purposes. So user goes and asks, hey, I want to analyze this instance for rightsizing in US East, and this is the account number. He gives the account number. The moment you give it, the agent actually does the analysis, and it gives the recommendations. This is how the recommendations look. And then if you want to look at the specific metrics of infrastructure, you can just go and ask, hey, can you please provide me the CPU utilization for the last 30 days? And this is what you see, the CPU utilization for the last 30 days for the instance. It gives you can see the day-wise utilization. And now the user decides, I want to go ahead and right-size the instance. The moment the user asks, I want to right-size the instance, this is the request that gets created, and the agent asks for the user's name, email, and then the business justification why he wants to right-size it. And all of this is collected as metadata, and that is actually being fed, and this information is also fed into the change ticket. So this way, the user don't have to kind of spend creating the change ticket manually. Okay, here you go. And the request gets submitted, and it's pending for approval. Once the approval is done, the change management process kicks in. Again, I wanted to show you how the bulk recommendations is available. And you can also provide it for the downloadable ask for a downloadable report, and the agent gives it, which you can download. And this is all, again, the link will be available for 5 minutes, and it's not available to the external users. And that's how we have built this whole implementation. This is the entire Agentic AI workflow to solve the problem of right-sizing. We did not buy any tool, we built it. We leverage the services that are available within AWS, and we also build the logic, how do we really go ahead and do the data aggregation, and was able to solve the problem at S&P Global. Thank you, everyone.
If you haven't seen one of these before, Catchbox or Crashbox, it does not hurt, it is soft, but you have to throw it for Q&A. My first question's in the back, so that's where this is going to go. Again, if it hits you in the head, you'll be absolutely fine. Let's see. Not my best throw of the day, but it is the last session.
So with one of the primary purposes of this being to reduce manual effort, I imagine at the scale you're using, everything's done through infrastructure as code. The second you make an automatic update, the infrastructure as code isn't valid anymore. How are you dealing with that? Is somebody going still manually to update the infrastructure as code?
The infrastructure. So no, I wanted to understand the question better. So when you say, it's all infrastructure as code, yes?
No, not your solution. So if I'm going to create an application in an account, I'm going to write infrastructure as code to stand up 1,000 EC2 servers. That's going to specify their size, right? So when you're right-sizing, automatically, how does the original infrastructure as code get updated? Does a developer have to go back and update it after all this has happened? And if that's the case, why don't you just use the infrastructure as code to right-size it in the first place?
So just to answer this question, right? So I think you're looking at the auto-scaling probably, right? How it works and does the update for all the instances, 1,000 instances in one go? Is that what your question is, or the auto-scaling?
Right. If your system is going to do the update through an MCP server automatically, it's going to change something from this instance size to that instance size, but the code still says it's the old instance size. So when the developer goes back and runs the code, it's going to switch it back.
No, we have not done that integration because, so if you're, okay, I do understand. So the next time when you start provisioning an instance, it's going to look back to the older instance type, and it's not going to pick up the new instance type. We don't do that change to the IAC template, but it is doable. This is a feedback that we have got, and we are working on the enhancement for this. One, how do we really, once we downsize the instance, how do we go back and check our IAC templates and make sure that is also updated? That's something that we have to integrate with the IAC pipeline, number one. Number two, how do we really go ahead and implement this across the auto-scaling groups? This is not implemented across the auto-scaling groups at this point of time. Does it answer your question?
Yes, I just don't understand the virtue of putting this much effort into something that changes the size of something when you could have just gone into the infrastructure's code and changed it there.
That has to happen, right? So once the instance type gets changed, it has to go and look at your IAC and make changes to it. That integration is pending.
Hey, that was a great presentation, and I like the idea of the talking to LLM.
A little louder.
But when everybody can talk to LLM and do the right sizing, it's like privilege for all the developers or any your SRE team or anybody, right? So in that case, how do you actually implement the guardrails? There should be some guardrail, a governance. Else anybody can go and play around, right? So how did you implement those guardrails?
So good question. So we have enabled some of the guardrails, and we have defined all of these in our code. So I cannot show the live demo, but in the live demo, if you ask something which is not relevant, the agent is not going to answer. It's going to give an error. It says it is not in the scope. It is not the relevant thing. It's going to answer that question. So we have actually implemented all the AWS the default Bedrock AgentCore guardrails in it, and through prompt also we have done a lot of prompt engineering, made sure the agent handles a lot of other toxicity and biases. It handles a lot of those. It doesn't hallucinate. We have changed several models to see whether it hallucinates or not. We have actually explored 3 or 4 models, did a comparison, did a model fit as assessment to see which model handles the scenario better. So all of those are in place, and it's also not going to allow you to implement it immediately. As I said, we have the scope-based authentication here, right? The scope also prevents you to look at larger data beyond what is requested. And number 2, it is also going to make sure that it is not going to allow, take you to perform any other action which you're not supposed to take. Again, you should have an elevated access if you're even asking for, go ahead and implement it right away. It doesn't do it. And there is a set of instructions that the agent also follows. We have also built that reasoning capability within the agent. It just doesn't really go ahead and execute whatever the user says. As I said, it's the way that we have built is we have built the harness around the model itself, right? So the reasoning capability is inbuilt. The agent is going to reason every time, and it's going to think, if I do this, we have also given what will happen, what is the destruction, what is the impact it is going to give if you go ahead and implement the change. So we have clearly called out everything in the prompt. We've handled all of those.
Okay.
So it won't. We have tested multiple scenarios. We have a whole lot of data sets that we have tried, and multiple scenarios, because we are highly regulated, and for us, it is important to make sure that the agent does not provide any wrong information to anybody or destructive information.
Yeah. Just another quick question. Just curious to understand, how would the policy changes of the S3 buckets and your secret key policies, would that work for that as well, or there is still human in loop for that? How are you handling it?
The S3 policies, no, we have not included here.
So this is more about right sizing. And it works for databases as well?
Yes.
Okay, thanks.
We'll go to the back of the room first, and then we'll head back to the middle.
Hi, good talk, by the way.
Thank you.
Do you guys do any evaluations in real time on the agent recommendations?
Yes, we do run the evaluation. But for the evaluations, we don't do it right away using this tool. We use our LLM observability. AgentCore has got its evaluations too, but at organization level, we use LLM observability tool. We have Langsmith implementation. Langsmith has got robust evaluation capabilities. So we do have data sets to look at what model, how the agent performs, how the response looks like. And we run the evaluations using Langsmith. We do offline and online and keep constantly improvising our agent response.
Got it. Thanks.
Perfect throw.
Thank you for the presentation. It was very good. I have one question. If you could elaborate on where do you see the end goal of agents, and where do you basically see all those agents working together in doing FinOps? Because you have basically created, I understood, a couple of one agent to do EC2 rightsizing, right? And you are exploring even more agents. So I'm wondering, how do you deduplicate, or what's your strategy on making all of those agents work together to solve the whole of FinOps?
So from an architectural perspective, it's a multi-agent collaborator. If you see, it's the underlying capacity or the underlying agent architecture will not change. When I say it's a multi-agent architecture, one, it's a supervisor agent is going to call the respective agent, and they're going to invoke the other calls. There is a tool calling involved here. So if you have to expand the scope to the additional resources, you just have to do the coding, what is needed to get the right sizing or get the recommendations for that resource. We have already expanded this to ECS, Fargate, RDS, and also to Lambda functions. But again, what we have not done is only for the Kubernetes, because that involves the horizontal pod scaling, and then we need to look at the pod scaling, which is very complex. So that's something that we decided we won't build as well. So we will buy that.
Okay.
And then it already does it. So there's already a collaboration that is happening, which we have defined in our MCP layer.
Okay, many thanks.
Got time for one or two more questions. Shoot your hands up nice and high.
Yep. A short toss there. Great presentation. Two questions. One is, have you, since you have MCPs, are you allowing your developers to just call those MCPs in, like if they have Cursor or if they have Cloud Code? And then the second question is, do you have other thoughts on how you might advance this doing shift left, like in coding assistant agents or whatnot?
The first question, right? So if you look at the MCP server, the agent interface along with the agent interface is something that we can offer. So anybody who wants to consume, they can come to a platform, they can use it. That's one offering. But I know with this whole AI, everybody wants to develop their own agentic AI solution. They wanted to build from the scratch. Some of them really wanted to consume our MCP. To answer your question, the MCP, we have actually an MCP server for this whole offering. That is something that we have rolled out to the divisions, and there are teams which have tested, and they wanted to plug it in as a part of their workflow. There are teams who do not really wanted to use that as an agent, but they still wanted to use individual MCP tools that the agents are calling, and they wanted to consume that as a part of their whole development workflow. They are doing that as well. So it's highly modular. You can actually plug and play. You can decouple it. You can use the way that you really want, how you really wanted to get the insights.
Last burning question. Oh, back here.
Oh boy. All right, here we go.
Aim for the wall.
God, oh God. It was good enough, it was good enough. Hi, good job. Question, just very basic. How many services are you covering with this technology? Like, you get Elasticache, databases, EBS, S3? Because I feel like EC2 is often the example to go with because everybody's kind of aligned on the metrics. But some of the other services, like people aren't fully aligned on what good is in terms of metric and performance. So curious what it covers. Yeah,
good question again. We don't want to really cover all the AWS services, native services or Azure services that we have available today. What we wanted to do is what makes sense to us. We are not again commoditizing it. We are not building a product, and we are not commoditizing it. We are not selling it outside, right? So we are just solving the problem at S&P Global within the organization at an enterprise level. We leverage the FinOps tool. My FinOps experts are sitting here. They know. So based on the recommendations, we looked at the services which are burning high cost for us. So we try to solve the problem only for those services, and that's how we picked up what are the topmost services we wanted to look at and tackle, and we picked up that services and then started incorporating that as a part of the solution.
Folks, a final round of applause for Anu, please and thank you.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.